In this video, we're going to look at notation and its use in probability. So the following notation will be introduced to you. So the first symbol looks like this E symbol, and that stands for is an element of. So things you could think about, you could say 2 is an element of even numbers, and you could use that symbol to represent that. The next one with the line through it is the negation of that element. So it says that such and such is not an element of. So you could say 2 is not an element of the odd number set. Now this little C symbol, it says it's a subset of. So for that, you could say that the set 2, 4, 6 is a subset of even numbers. Here we have subset with a little line under it, and that just stands for is a subset or equal to. So in cases where the subset represents the whole set, that symbol could be used. Now this U type symbol, the next one down, means the union between two sets. So we're going to see an example of this coming up in a minute. And the next one looks like a bit of an N, and it stands for the intersection between two sets. So the union and intersection we'll explore in more detail in just a moment. Next we have this sort of O or zero shape with a line through it, which means the null set or an empty set. So that's just a set where it has no elements inside it. This E you might have seen in a previous video stands for the universal set. And again, we've simplified it in these videos. It's technically a little bit more squiggly than that, but we'll use that symbol to represent the universal set, which contains all elements in the sample space. Next, we have this A dash, and that stands for the complement of A. So that will have all elements that do not exist in A in it. So you could also have B dash, which would be the complement of B, or C dash, which would be the complement of C. So all of those just stand for the complement of a set. And then this backslash here means except or excluding. So you could exclude a particular element if you wanted to by using that backslash. So now we're going to have a look at unions and intersections. So the union of two sets, which we can denote with A and then that U-type shape B, is the set of all elements in A and B or both. So on a Venn diagram, this blue shading shows you what the union would look like. It's got all the members of A, all the members of B, as well as the members that are in both A and B. The intersection, however, which we can represent as A and then a little N type symbol, B, is the set of all elements that are in both A and B. So this is different to our union, and that's most clearly seen on a Venn diagram where we can see that the intersection is all of these elements that would be in set A and set B, but they can't be in one and not the other. They have to be in both to be part of the intersection. So it's that overlap here of the Venn diagram. We will next consider the numbers 1 to 10 inclusive, and we're going to let A be the set of 1, 2, 3, 4, and 5, and B be the set of 2, 4, 6, 8, and 10. For part A, we want to represent this sample space using the Venn diagram. 1 is part of A, 2 though is part of A and B. So it's going to go in this overlapping region to say that it's in set A and B. 3 is only in set A. 4 though is in set A and B, so it will go in the overlapping region. 5 is only in A, and then we have 6, which is only in B, 8, which is only in B, and 10, which is only in B. And now, because we're considering the numbers 1 to 10 inclusive and all of them in between, we've also got 7 and 9, which haven't been put in here. So we're going to sit them outside of the two circles, which represent sets A and B. Next, in part B, we want to describe using set notation the union between A and B. So we remember that the union has this symbol, A union B, and it's going to be equal to the set of numbers that are in A or B or both. So we have 1, 2, 3, 4, 5, 6, 8, and 10. So that there is the set of A union B. So that's all the numbers that essentially aren't 7 or 9. For part C, we want to describe using set notation the intersection between A and B. So we remember that A intersect B is how we describe that. And this is the set of all numbers that are in both A and B. And on there, we can see for the Venn diagram, it's the overlap. So it's just the set of numbers 2 and 4. So next, we will look at mutually exclusive events. So two events A and B are mutually exclusive if their intersection is equal to the null set. So on a Venn diagram, that means there's no overlapping region, which means there's no elements common to A and B. So this means that if two events A and B are mutually exclusive, they cannot both occur at the same time. Mutually exclusive sets are also known as disjoint sets, if you see that come up. Examples of mutually exclusive events include odd and even numbers. You can't have a number that is odd and even at the same time. Turning left or right, so you can't turn left or right at the same time. You can only do one or the other. Tossing a coin. So in that situation, you can only obtain a head or a tail, not both. And our last example is drawing a king or a queen from a deck of cards. You can't draw both a king and a queen at the same time. So if A and B are mutually exclusive events, then the probability of A intersecting B is equal to the probability of the null set, because there is no elements that are common to both. Okay, that's what it means to be mutually exclusive. So that means that the probability is 0. Next up, we're going to look at complementary sets. So A dash, if you remember from before, represents the complement of A. That is, it contains all of the elements in the sample space that are not in A. So for a Venn diagram, A dash has been shaded in blue. So it is everything in the sample space that A does not contain. So as A union with A dash represents the entire sample space, all right? So if you have everything that's in A and then everything that's not in A, you're essentially looking at all of this box, which is all of the sample space. We can say that the probability of A plus the probability of the complement of A is equal to 1. And this gives rise to a really, really useful formula. And that is that the probability of the complement of A is equal to 1 minus the probability of A. Or you could even say the probability of A is equal to 1 minus the complement of A. Whatever way you want to think about that. Complementary sets are also mutually exclusive. So that means that A intersecting A dash is the null set. So because of that, we know that the probability of A intersecting A dash is going to be equal to 0. Here we're going to look at complementary sets. A coin is flipped 4 times and we want to find out what is the probability that at least one head is obtained. So you could go through and you could set up a tree diagram or something and work out all the possible events that lead to having at least one head in it, and then you could add that up. Or an easier way would be to look at the complement of it. So here we're going to say that the probability of having at least one head is equal to 1 minus the probability of obtaining no heads. So if that's the case, we only need to consider the one line on the tree diagram that actually leads to us having no heads. So for our first flip, you could get a head and a tail, and then everything along that branch from the top is going to have at least one head in it. From here, we could get a head and then a tail on the second flip, and everything on this branch will then have at least one head in it. Then we could go head and tail once again on our third flip, head or tail on our last flip. So we've got all of this tree diagram that we don't actually have to write about because we're going to consider the complementary of our event. So next we need to remember that flipping a coin, there's always a 50-50 chance of getting a head or a tail. So it's going to be a half, it's going to be a half here, a half here, and a half here. And we multiply along our branches to get that the probability of getting no heads or all tails is equal to 1 over 8. So that means we can finish up our working up here and say that it's 1 minus 1 over 8, which equals 7 over 8. So that there is the probability that at least one head is obtained, and we've worked it out by basing it on the fact that we can just do 1 minus the probability of no heads being obtained, and that will give us the same thing. So after this video, you should be able to understand and use basic set notation and symbols for probability. You should understand and be able to list elements belonging to the union and intersection of two sets. You should also understand mutually exclusive events and rules that apply for that. And finally, you should understand complementary sets and know that A union A dash is the entire sample space, and A intersecting the complement of A is the null set.